In this video, the learner will use deductive reasoning to form proofs in paragraph or two-column form. To prove a conjecture, we're going to use deductive reasoning to form what's called a proof. A proof is a logical argument where you provide evidence for each new statement made. When we have a statement in our conditional format, if, our hypothesis, then conclusion, we have pieces of this that we'll use in our proof. The hypothesis is our given information. This is what is known before we've completed the proof. Our conclusion is what we have to show or prove. That is going to be our conclusion when we're done with our proof. The proof process starts with our given information. So step 1 is to list all of our given information, and if we can, draw a diagram to illustrate that information, and that'll help us with the next few steps. Step 2 is to state the theorem or the conjecture to be proven. So what are we trying to get to? Where do we need to end up? Step 3, we're going to create a deductive argument by forming a logical chain of statements, linking the given to what you're trying to prove. So it is a step-by-step process, linking them together. Step 4 is to justify each statement with a reason. So those chain of statements have to be justified. The reasons are going to include definitions, algebraic properties, postulates, and theorems. And step 5 is to state what it is that you have proven. So once you're done with your proof, you should reach the conclusion you were trying to get to. Now, this is the process that you'll go through every time, but there are different ways to represent that process, and these are the different forms of proof. The first one that we're going to go over is a paragraph proof. So given that M is the midpoint of segment XY, we're going to write a paragraph proof to show that segment XM is congruent to segment MY. So we have our given information and what we're trying to show, and those are our step 1 and 2, is to write down what we're given to illustrate a picture and what we're trying to prove. So those are our steps 1 and 2 here. Our steps 3 and 4 are then to connect statements together to show why segment XM would be congruent to MY. Well, our paragraph will then say, starting with our given information, if M is the midpoint of segment XY, then from the definition of the midpoint, we know that the distance from X to M is the same as the distance from M to Y. That's the measure here. This means that segment XM and MY have the same measure. Notice that we made that statement and then we provided that reason with the definition. By the definition of congruence, there's your reason. If two statements have the same measure, then they are congruent. So our reason is the definition of congruence, and our statement is if they have the same measure, then they're congruent. So those are our steps 3 and 4 to provide that evidence, linking those statements together. And step 5 is to restate our conclusion that XM is congruent to MY. Now, I have this little starred box here. Sometimes it's really helpful to try and work backwards in a proof, thinking about where you have to end up and where you have to get to first, and work your way backward through the proof. We're going to be using these algebraic properties as we work through some of these proofs next. So you'll need the addition property, subtraction, multiplication, and division. Those are exactly what you've done in algebra. When you have an equation A equals B, you can add the same value to both sides. If you have A equals B, you can subtract a value, multiply a value, or divide by a value as long as that value is not 0. We next have the reflexive property of equality that states something is equal to itself. So we have A equals A. The symmetric property is if A equals B, we can conclude B equals A, which is really just switching the order. So if A equals B, B equals A. Transitive property, if A equals B, B equals C, we can cut out that middleman and say that A equals C. And this is transferring that equality. Because we knew they were both equal to B, we can say they're equal to each other. The substitution property is if A and B have the same value, we can replace one for the other in any expression or equation. The distributive property is if we have a value A times an expression B plus C, we have to make sure that A gets multiplied by every value in that expression. So A times B plus C equals AB plus AC. These properties are what we're going to use as reasons in our proofs. So prove that if negative 5 times x plus 4 equals 70, then x equals negative 18. We're going to write a justification for each step. So we start out with our original equation, or what we're given. Notice this was the hypothesis of that statement. That's our given information. This conclusion, x equals negative 18, is what we're trying to get to. So we have our steps in between that we're going to use. So what we could do to this first is distribute. So multiply negative 5 times x and negative 5 times 4. And then we have the substitution property because we know negative 5 times 4 is negative 20. Then we're going to add 20 to both sides. That's our addition property of equality. And then our substitution, because negative 20 plus 20 is 0, and 70 plus 20 is 90. Then we can divide both sides by 5 by our division property of equality. And then by substitution, because negative 5 divided by negative 5 is 1, and 90 divided by negative 5 is negative 18. And notice we've reached our conclusion that we were supposed to get to. Now, this is not a formal proof. This is just writing out our steps and justifying each one. If we want to put this in a formal proof, we could use what's called a two-column proof. It's more formal than a paragraph writing it out in words. So we will start out with a T-chart. We'll have a column for statements and a column for reasons. The statements are the steps. So the steps in our problem, or the steps that we're trying to reach our conclusion with. And the reasons are going to be the evidence. Those are going to be the justifications, the properties, and why we said that statement over here. We could actually place all of those steps and justifications from the previous problem into that two-column proof. So starting with that very first statement and going to the next, and so on and so forth until we reach that conclusion. And then that right-hand side would be our justification. Okay, here we have an example. If the formula to convert a Fahrenheit temperature to Celsius temperature is C equals 5/9 times F minus 32, then the formula to convert Celsius to Fahrenheit is F equals 9/5 C plus 32. We're writing a two-column proof to verify this conjecture. So remember, we begin by stating the given and what you have to prove. So our given is the formula from Fahrenheit to Celsius. We're trying to prove from Celsius to Fahrenheit. So we're starting with what we're given, and our goal is to get to this. Remember, sometimes it's helpful to work backwards, so we're going to think about how we can manipulate that given equation to end up looking like what we're trying to prove. So I know I'm trying to solve for F. So what can I do to this equation to solve for F? Well, first I can get rid of that fraction, so I would multiply by 9/5 on both sides using the multiplication property of equality. Then I need to substitute, because I know 9/5 times 5/9 is 1, so I'm left with F minus 32 on one side and 9/5 C on the left side. To solve for F, I need to add 32 to both sides, so using the addition property of equality. And then again, I'm going to use substitution to say 9/5 C plus 32 equals F. Now, we're almost there. We have F equal to something, but it's on the wrong side of the equation. So what I have to do is flip this equation using the symmetric property of equality. Now I have f equals 9/5 c plus 32, which was what we were trying to prove. That is our conclusion. Here is a problem I want you guys to try. If 5x plus 1 divided by 2 minus 8 equals 0, then x equals 3. Write a 2-column proof to prove that conjecture is true.